time to do the 2023 Spec WACE exam. This will be my 100th prac exam that I've done. If you count it all up, that's probably about 300 hours worth of just prac exams alone over the past 2 years, which is about, if you average it out, about an exam a week. But obviously it's been compressed during exam seasons and stuff like that, where I do like 1 or 2 exams a day. But yeah, wow. It's crazy to think about this will be my last exam I ever have to do, or for ATAR at least. So yeah, I'm not sure if I'm going to do that methods one. Maybe if I have some free time, which I probably am going to have a little bit of during the start of December, I might do 101, my 101st exam. But yeah, this is it. Tomorrow it'll be my last WACE exam as well. It's kind of crazy to think about. So yeah, let's just get started. We've got 15 minutes on the clock. 48 marks. How many pages we got? I like how only now, recently, I've started to have a look at how many pages we got. Yeah, alrighty. So I think it was 13, already 12 pages. So okay, we're back and let's get started now. 15 minutes on the clock. The graph of that is shown below. The constants A, B, and C and K are positive. Complete the table by determining the values for A, B, C, and K. So let's see. We can figure out A and K because of our zeros. So since X minus B must equal, what do you call it? Wait, why can I not reverse? Oh, okay, whatever. So X minus B, so 4 minus B must be 0, so we'll say B is 4. A can be 2 or 1, sorry, because it's at -1. And let's see, C is our vertical asymptote, so C will be at 3. And let's pick a point, let's pick 0, -1. So we have that -1 is going to be equal to K outside of 0 plus A, which is going to be 1, and then 4 all over 0 minus C squared, so that's going to be -3 squared, so 9. So it's equal to 4K on 9. So -1, so then K is going to equal -9 on 4. Wait, it says A, B, and C up. K is positive though. X minus, oh, because this will be -4. So -4, so then K is 9 on 4. Okay. There's not really any other points to go off of. So I think that'll be our values. 9 on 4. -1, 0 plus A is 1, 0 minus 4, -3 squared. 9 on 4. Okay, P of Z is equal to a fifth order polynomial of real coefficients. It is known that P of Z equals Z minus ZO QZ, because ZO is real. QZ is a fourth order polynomial. Two roots of P of Z are that. Determine Q of Z in expanded form. Okay, so since real coefficient therefore we have that Z equals 1 minus I and Z minus or Z equals 2 square root of 3 or 2 minus square root of 3I are also roots. Therefore we have that Q of Z is going to equal 1 minus I, 1 plus I times 2 minus square root of 3I times 2 plus square root of 3I. So if we just take this as the difference of 2 squared, A squared, which is 1, minus B squared, which is going to be that'll be -I squared, so then plus 1. Wait, is that right? I think this is fine. Oh wait, no, because it's going to be Z minus. So Z minus 1 plus I, and then Z minus 1 minus I, and then Z minus 2 minus square root of 3I. and then z minus 2 plus square root of 3i. So then this will be equal to z squared. We're going to have minus z minus zi minus z plus 1 plus I, and then plus zi minus I plus 1. That'll be negative I squared. And then over here, we're going to have z squared minus 2z plus square root of 3zi. And we're going to do minus 2z plus 4 minus 2 square root of 3i. And then minus z square root of 3i minus square root of 3 zi plus 2 square root of 3i. And that's going to be negative 3i squared, so it's going to be plus 3i. It's plus 3. Okay, now let's see what we can cancel. We can cancel that, cancel this. So this is going to equal z squared minus 2z plus 2. And then we can cancel these and that. So then this will be, let's see, this is correct, minus 2z, another minus 2z. Okay, so then this will be z squared minus 2z minus 4z plus 7. And this is going to equal, God, what are these terrible, terrible things? So z to the power 4 minus 4z to the power of 3 plus 7z squared minus 2z to the power of 3 plus 8z squared minus 14z plus 2z squared minus 8z plus 14. So then let's see, this is going to be z to the power of 4 minus 6 z to the power of 3 plus z squared is 7, 15, 17 z squared minus 22z plus 14. I believe this is right, minus 2z to the power of 3 plus 8z squared minus 14z plus 2z squared minus 8z plus 14. Okay, determine the values of the coefficients a, b, c, and d. So a is going to be 1. B is negative 6. C is 17, and D is 22. D equals 22. Was it negative 22? It was negative 22. God, that was bad. That was terrible. Using the substitution, u equals that. Evaluate exactly. Okay, so let's just do dx du. This is going to equal 119. Then we have let's do x is equal to 119u plus 1. So 119 is equal to x minus 1 on u. Is that how I'm going to do this? Okay, I think I'm just going to, actually no, never mind. I can see how it's going to work, because I sub in x here, we're going to 119 and we're going to 118. Okay, it's fine, it's fine. So we can say when x is equal to 120, u is equal to 1, and when x is equal to 1, u is going to equal 0. So then let's sub this in, and therefore, so 120, oh sorry, let's just do 1, so u equals 1, we should just do 1, 0, and then it's going to stay as 2. Let's change this. So then dx is equal to 119 du. 2 plus 4 of x, which is going to be 119, plus 1 for u, plus 1 plus 118, all over 119 to the power of 3 dx. And 19 du. So then this is going to be 10. Let's change this to 119 du. So then this is 2 plus 4. I'm going to get u plus 1 to the power of 3. And then this is all times 119 du. So if we can pull out a let's put a value of 2 and then 119, so this can be 238 of integral from 1 to 0 of 1 plus 2 u plus 1 to the power of 3 du. Because I put out a factor of 2 and then 119, okay? So then we can anti-differentiate this, so this becomes u plus, it's going to be 2. If I raise the power by 1, that's going to be 4, so it's going to be a half actually, so u plus 1 over 4, sorry, over 2, 4 to the power 4, from 1 to 0, so it's going to be 238 of 1 plus that's going to be 2 to the power 4, so 2, 4, 8, 16, so it's going to be 8, minus 0 plus 1 on 2, so this is going to be 238 of 9 minus a half, so it's 18, so 17 on 2. Oh god. What the heck? So it's going to be 119 times 17, which is going to be, why are they making me do this? 70 times that is 63, 7,700, and then 1,190. So 3, that's 13, 2, 2. It's going to be 9, 0, 1. Oh, 2023. Very smart. Whoever made that up is a devil. That is a terrible question. Jesus Christ. Wow. Okay, well, this it has to be correct, right? I mean, 2023. Come on now. Okay, the graphs of function f of x and g of x are shown. Sketch the graph of g negative 1 of x on the axis below. So let's just find some points. We have an open dot at 1, 2, so we go 2, 1. It's an open dot. That connects up to 3, 0, so we go 0, 3. Like that. And then we also have a point at 1, 3, so we go 3, 1. So open dots. And then that's going to go down to negative 3, 3, so we'll go 3, negative 3. So like that. Okay. So I go to state the value of g of f of negative 1 of 0. So f negative 1 of 0. So I want to find the y value, 0. It's going to be negative 1. Negative 1. Therefore, g of negative 1 is 3. Okay. Determine the set of values such that f of g of x is defined. So f of x is defined for, so let's say domain of f of x is -4 less than or equal x less than or equal to 2. And then, so the range of g of x is, oh god. So we have 3. What the heck? So we have 3, and then 0. So we have 0 to 2. So we have 0 less than or equal to x less than or equal to 2, or x is equal to 3. Values such that f of g of x is defined. So we can take all values along the range of g of x. So we can sub in any value from -3 to 3. All encompassed in domain of f of x. Therefore, we have that x is a part of the real such that x on -3 less than or equal goes from -3 to 3. So -3. Okay, it doesn't want to undo that one. So -3 less than or equal to x less than or equal to 3. Sketch the graph of -f of x on the axis below. So I'm going to want negative absolute value of f of x. So I'm going to start 1, 1, and just go up. And then we go up to 4, -4, 3. So like this, and we'll go like that, and then something like this. Okay. The equation has infinite number of solutions, with the solution set being determine the values of constant a and k. -3. So x plus 1. Let's have a quick sketch. So x plus 1 is going to have a critical point here. And then it says from -3. So maybe x is -3 is here. Let's do another line. And then -1. So a must be but that's a negative of that. So negative means it's going to come up like this and go down. Okay. So then it's going to be so this is x equals -3, -1. X plus a will have critical point at x equals -a. This will be the x equals -3 from sketch. Therefore, a is equal to 3. And then k will equal the value of, so we'll say x plus 1, so at x equals -3, x, so -3 plus 1, it's going to equal k minus, oh my god, my pen is doing this weird thing again. So equals k minus the absolute value of x on -3 plus 3, so that's going to be 0. So then k is going to equal 2. Okie dokie. I think we're good here. Let's see, we're -3. Okay, it's 2. Alright. Consider two planes given by the Cartesian equation. Explain why these planes are not parallel. So let's say the normal to these planes and then let's say this is plane 1 and plane 2. So plane 1 is, it'll be 1 minus 3, 3. And then plane 2 is 2, 1, negative 1. As these are not scalar multiples, they're not parallel. Each other. They are not parallel. They're not scalar multiples of each other. The planes themselves what is it doing? It like thinks the tip is like lower than it actually is. It's really annoying. Okay, so state the geometric interpretation of the solution in the above simultaneous equations. So it must be aligned through space. So we'll say line through space. So planes intersect through a line in space. So let's rewrite them again. X is equal to, hold on. So x minus 3 plus 3 equals 9. And then we have 2x plus y. It says 2x plus y minus z equals 4. So let's say this is 1 and then this is 2. So if we do, let's say 1 plus 2, we get 3x plus or minus 2y minus 2z is equal to 13. Does this help me in any way? Does this help me in any way, shape, or form? I want the vector equation for the intersection of these two planes. And what if I just do y is equal to 4 plus z minus 2x. See if I sub this into here, minus 3, so be minus 12 minus 3z plus 6x plus 3z equal to 9. I think this is about a spot to go. So x minus, okay, let me make sure I get this right, because minus 3y, so minus 3z plus 6, okay? So then I'm going to get 7x, the 3's are going to cancel, it's going to be equal to 21, so x is going to be equal to 3. Okay, nice, so then let's do this. Okay, we can get rid of that, I don't actually need that. So x is going to equal to 3, so then y is equal to 4 plus z minus 2x. or minus 2 times 3. So y is equal to z minus 2. And we'll say let z equal, I don't know, k. Then r is equal to what's a point that fits on this curve? So let's say 0. For this one, let's just say y is 4. So 4, 0, plus lambda of, well, x is 3, so it doesn't actually move. Oh, okay. So if x is 3, this is 6. So then let's say that y is negative 2. So 3, negative 2, 0, plus lambda. Now, x doesn't move. Y moves with k minus 2, and then that's just going to be k. Okay. So 3, negative 2 work. Minus 3 plus 6, and then z is 0. Yep. Alright, that looks pretty good. Z minus 2. Actually, no, this would be k as well. Because the direction is with z. Because this minus 2 is actually the value that, yeah, so lambda of k. So we say that k is 1, we're going to get 3, negative 1, and 1. Let's see if that fits. That's going to be 6 plus 1 minus 1. 6 minus 1 minus 1, okay. 6 minus 3 is going to be plus 3 plus 3. That doesn't fit. Oh no, because that's 3, just 3. Okay, x is just 3. Yeah, okay. And that works. So vector equation for the intersection of these sides. Yep, that's correct. Okay, whew. This is getting stressful. Okay, page 9, and there was 12, right? What is that? That looks disgusting. Okay. Solve the equation. So let's say that 2 minus 2 square root of 3 so let's say square root of 4, and it's plus 4 times 3, which is 12, it's going to equal 4. So then therefore, so to the power of 4 is equal to 4 cis of, so it's a half positive but a negative, so pi on 3, negative pi on 3, because we'll be going that way. That'll be 60 degrees. Negative pi on 3 is negative sine pi on 3, which is 60 degrees. So yep. So then let's say z to the k is going to equal square root of 2. Cis of theta. Okay, so square root of 2 cis of negative pi to 12. Negative pi to the 12 plus 2k or 2 pi k all on 4, given that k is equal to 0, 1, 2, and 3. So then we have that 0, or z0 is going to be square root of 2 cis of negative pi 12. z1 is going to be square root of 2 cis of negative pi. If I multiply this by 3, I get 6, so it's going to be 5 pi on 12. So then z2 is going to equal square root of 2 cis of, so this would be 11 pi on 12. And z to the power of 3 is going to equal square root of 2 consists of, let's make sure I get this right. I'm going to get 17, which is 5 over, so I got negative 7. Yep. There's negative 7 pi plus 6 is going to be the negative pi. Alright. So that's my answers. The shaded region is bound by the curve and the line x equals 4. Show that the area of this region is given by the definite integral of that. State the value of A. Okay, so the radius is 2. And this is here 3, 4. So then this part will be 5, 4. So A is going to equal. So we'll say A equals 3 plus 2, which is going to equal 5. And then, so we have y squared. So let's rewrite this. So x minus 3 squared plus y minus 4 squared equals 4. So we have that y minus 4 squared is going to equal 4 minus x minus 3 squared. Now it has a 2 in there. Okay, so then y minus 4 is equal to the square root of 4 minus x minus 3 squared. So then y is going to be the square root of 4 minus x minus 3 squared plus 4 on the outside. And then you take away value from this minus 4. So then area is going to be equal to integral from 4 to 5 of square root of 4 minus x minus 3 squared plus 4 minus 4 dx times 2 due to symmetry. Symmetry around y equals 4. So then this simplifies to 2 square root of 4 minus x minus 3 squared. I hope I don't have to anti-differentiate this. And I don't think I'm going to have to. I hope they give me something nice to anti-differentiate with. Yes! Okay. So area. So let's just rewrite this. 0 to 5. Sorry, 4 to 5 of it was 2 square root of 4 minus x minus 3 squared dx. So x minus 3 equals 2 sine theta. So now let's do x is going to be equal to 2 sine of theta plus 3. So then let's say dx d theta it's going to equal 2 cosine of theta. So then we'll say dx is equal to, we'll say here dx is equal to 2 cosine of theta d theta. Then let's find out bounds when x is equal to 5. We can have x minus 3, which is 2, so then sine of theta is equal to, so theta is equal to pi on 2. And then when x is equal to 4, you can have 1.5, so sine is going to be equal to pi on 6. So theta equals pi on 6, sorry, sine will be a half, and then theta will be pi on 6. 1, and you need sine of theta to be a half, so you need 30 degrees, okay? Therefore, we're going to have from pi on 6 to pi on 2, I'll put this 2 on the outside, square root of 4 minus, then x minus 3 is going to be just 2 sine squared of theta, so minus 4 sine squared of theta, because that minus 3 is going to get rid of that, and then we have to square this. Okay, and then dx is 2 cosine of theta d theta, and this is going to equal So we can pull a factor of 2 out from here and from here. So we're going to get 8 of pi on 6, pi on 2. Inside here is going to become cosine of theta, or cosine squared of theta, but then you square root it. So, and then we have this cosine of theta here. So cosine squared of theta d theta. And then we can use the fact that cosine squared of theta is going to equal cosine of 2 theta plus 1 all on 2. From rearranging this bad boy. So this would be 4 pi on 6 pi on 2 cosine of 2 theta plus 1 d theta. So then this is going to equal 4 outside of negative a half of, actually no, just a half of sine of theta, not negative, sorry. So half of sine of theta plus theta, no, 2 theta inside the sine. From pi on 2 to pi on 6. So this is going to be 4 of, so sine of 2 of pi is going to be 0, plus pi on 2, minus, pi on 3 is going to be square root of 3 on 2, so square root of 3 on 4, plus pi on 6. So this is going to be 4 outside of, so let's see, if I make this the common denominator of these 12, I'm going to get 6 pi and 2 pi, so 4 pi on 12, so pi on 3, minus square root of 3 on 4, six pi on 12 minus 2 pi on 12, 4 pi on 12, pi on 3, so I get 4 pi on 3 minus square root of 3, and then this would be units squared. Last page. The following simultaneous equations A and B are real numbers. In order to determine the value of a squared plus b squared, it is useful to consider the complex expansion for a squared plus b squared. Hence, otherwise, tell the exact value of a squared plus b squared. Okay. So we want the complex expansion of this. So a plus bi squared is going to be a squared plus 2abi minus b squared. Yep, so then a squared plus 2abi minus b squared times a plus bi. So this would be a plus bi to the power of 3. It's going to equal that. And this is going to equal a to the power of 3 plus a squared bi plus 2a squared, what am I up to? 2a squared bi plus 2b squared, and then it'll be I squared, so minus, and then minus ab squared plus, no, minus b to the power of 3i. Now, am I going to have to group the real and not real terms? This is what I'm going to have to do. So let's see, a to the power of 3 minus 3ab squared plus, let's see, a squared b, 3a squared b minus b to the power of 3i. Okay. Hmm. So this is equal to, if I'm going to understand, it's going to be 14 plus 3 minus bi squared minus 2 squared 3. I want to find a squared and b squared. So a to the power of 3 so this complex number expands to this. Now what happens from here? I want to find a squared plus b squared. What happens from here? So if I find, let's say, the third root, 14 squared plus 2 square root of 5 squared is the square root of 196, and 4 times 5, 2, 6. Two one six. Two and 108. 2 and 54. 2, 27. 3, 9. 3 and 3. So it's 6 to the power of 6. Or 6 to the power of 3. So if I find 216. I feel like I'm very close, but I'm not sure. Because I have some complex number AB. So this is AB squared. And AB squared. Therefore, third root of 6 to the power of 3 is clearly going to be 6. I'm going to say a squared plus b squared represents magnitude of a plus bi. Therefore, the magnitude of what if I do like this? Power of 3 is equal to 6 to the power of 3. Then a plus bi, just the magnitude of that. It's going to be equal to 6. Therefore, a squared plus b squared represents square of magnitude of a plus bi. 36. Is that it? Not sure if this is it. Not sure. From here, I think this is the answer, but I'm not sure my explanation makes sense. The magnitude of this. So maybe the magnitude of a plus bi to the power of 3 is going to be equal to 6 to the power of 3. I think that fixes things up a bit. I think that might be the answer. Not sure. I think I've seen this question somewhere, but I definitely do not remember if this is the answer or not. But I think it fits too nicely to not be the answer, so I'm going to leave it as is. Because this represents some number, and you're multiplying some complex number, and you're multiplying with itself 3 times. And when you do that, you get that the magnitude of that is going to be 6 to the power of 3. Oh no, it can be square root of 6 to the power of 3. So going to be a third root, square root of 6 to the power of 3 will be equal to 6. Wait, no. So it's a half, so 6 to the 6. Then a squared O plus b squared equals 6 to the 2 on 3, or 1 on 3. I think. Definitely an interesting question. But we'll see if that was the answer or not. So yeah, I'm gonna move on to calculator assume now, so yeah, later. Okay. Time to do calculator assume. They're gonna cast how many pages? Okay, 23 pages. I think one less than last time. So let's just get started. Wait, hold on. I need to put my timer back on. Wait. Now we're back. Okay. A Cartesian equation of the sphere is given by that. Write the equation of the sphere in vector form. So this is going to be x minus 2 squared plus y minus y plus 1 squared plus z minus 3 squared equals negative 5 plus 4 plus 1 plus 9. That's going to equal 9, therefore it's going to be an absolute value of r minus, now the center is going to be 2, negative 1, 3. It's going to be equal to, and the radius is going to be 3, so 3. A line has a vector equation of that. Determine the point of intersection between the line and the sphere. So let's just sub in this equation. So 7 plus 3 lambda, negative 1 minus lambda, and 9 plus 4 lambda. It's going to be, oh wait, hold on, minus 2, negative 1, 3. It's going to be equal to 3. And I'll say cas lambda is equal to. So we need to solve for dot product between u, so 7 plus 3x minus 1 minus x, 9 plus 4x. Actually, no, this isn't a dot product. I'm going to solve for the normal of this. 7 plus 3x negative 1 minus x plus 4 minus 2 negative 1 3. It's going to be equal to 3. So right, lambda is negative 2 and negative 1. Therefore r is equal to u given x is equal to negative 2, 1, 1, 1, or negative 1 will be 405. The complex number wc is shown along with the complex number wz and wz squared. Express wz and wz squared in exact polar form. So wz is going to be 2 cis of 1, 2, 3, 4, 5, 5 and 6. And then wz squared is going to be cis of pi. This represents successive. So magnitude of complex number slash vector is scaled by factor of half. And I'll just say half, and rotated anti-clockwise. I bet you was going to ask me what is the complex number z. Anti-clockwise around origin, pi on 6 radians. Right, that is anti-clockwise, right? Am I being dumb? No, yeah, it is anti-clockwise. Yes, okay. Yep, determine z in exact polar form. So z will be equal to, no, it's half, so half cis of pi on 6. Successive multiplications of z minus 1. Z negative 1 is equal to 2 cis of negative pi on 6. So then magnitude of complex number slash vector scaled or multiplied by a factor of 2 to doubled. So multiplied by a factor of 2. I'll say here or doubled, and then rotated clockwise around origin. Wait, up here, oh yeah, this is anti-clockwise, around origin, pi on 6 radians. So far, calculator assume is much easier than the other, than calculator 3. Okay, it's given by x and y, it's given negative 4, that's given by the constant k, so we have negative 4 equal to k of 1 times 2 is 2, so k must be negative 2. Determine the equation of solution curve that contains the point 1, negative 2, so we'll say dy dx is equal to negative 2xy. So then we have, let's do 1y here, it's equal to negative 2x dx. So we have ln of y is going to be equal to negative x squared on, just negative x squared plus c. And then, so we have 0.1, 2. So then we have ln of 2 is going to equal negative 1 plus c. So c is going to equal ln of 2 plus 1. So then we have ln of y is going to equal negative x squared plus ln of 2 plus 1. So y is going to equal, well, can I just leave it like that? Not sure. Y is going to equal 2e1 minus x squared. And 1, 2. It looks like I'm just going to follow something like this. Let's see if I curve off. Like that. Doesn't look like it. I guess it does though. And then maybe something like this. I'm gonna guess it's symmetric. Actually, wait, I can just check. Let me go to differential equation graph. dy dx is negative 2xy. My initial condition will be 1, 2. Let's graph u. Yeah, looks like I did it pretty good. See if I can zoom out. Zoom out a bit more. What is the rate? Looks like a little bit past 5. So maybe about here. and it is pretty symmetric. So like that, and then okay. Why did you go to 2? And then I can graph this actually on my graph. So that's y. So let's see, 2e 1 minus x squared. Does that give me what I think it should give me? Looks like it does. And y-intercept is at 5.4. Yep. Okay. Complex numbers w and z are shown in the arc and diagram below. It is known that. Oh god, what is this? Okay. Arc of z is theta. So this is 3, and this will be theta. So less than pi 4, okay. And this w here is also going to be theta, because that is 2 theta, z minus k, where the imaginary value of k is 0. K is greater than 1. Determine a simplified expression for k in terms of theta, justify my answer. So this here is k, because it's minus k. That's 3. And then since that's horizontal, this also must be theta. So this value here is 3. So this is 1.5. So let's graph this. This must be k as well. So since I know that this is horizontal, this angle here must equal this angle here. So these must be isosceles triangles, or that must be an isosceles triangle. So then that must be half. Yeah, so then let's do boom. This is theta. My hypotenuse would be k, and my adjacent side is 1.5. So we have cosine of theta is going to be equal to adjacent over hypotenuse. So k is 1.5 all over cosine of theta. Maybe I'll say 3 on 2. Okay. The factory produces boxes of breakfast cereal with a labeled weight of 1 kilogram. Let mu denote the population mean, the population standard deviation. Okay, to maintain quality, denote the sample weight. So n is equal to 400, which is greater than 30. Therefore, normal distribution. And we are back. Continue. My dad just came into the room, and then we went to do some other stuff, and then yeah, we're back. So, what are we up to? Distribution for the mean. Wait, okay, so let's do mu of x is equal to 1.01, and the standard deviation of x is going to be 0.05 all over square root of 400, so let's divide by 20, is 0.0025, therefore x is going to be approximately a normal distribution of 1.05 and 0.0025 squared. So the probability that the sample mean is more than 5 grams above the labeled weight. So yeah, probability that x dash is greater than or equal to 1.005. There's going to be a norm CDF of 1.005 to infinity, where my standard deviation is 0.0025 and 1.01. Labeled weight is 1. Okay, so this is going to be equal to, so normal CDF, and you set this as my copy and paste. 1.05 to infinity of 0.025 of 1.01. So 9772 or 0.9772. The sample mean on a particular day is that, well, the sample standard deviation is 50 grams. For the population mean weight based on this sample, so let's say 0.05 kg. So that is equal to the sample standard deviation. And it's 400, so 0.05 on square root of 400 to, oh wait, that's what we did before already, so 0.0025, and then I'll say for, how much is what, 95% confidence interval, we'll say that k equals 1.96, and margin of error is equal to 1.96, 0.0025. We'll also say mean of x dash is equal to 1.5. So that. So this is 0.0049. Therefore, it's 3 decimal places. So 1.05 minus 0.0049 is 1.045. That's not equal to pretty much 1.1. Oh, never mind. Mu, that's not equal to 1.055. You're kidding me. How much did I just lose? Wait, I went way past it. Oopsies. Oh my god, you're kidding me. Okay, I'm gonna pause and be back. And we're back. There might be like a second or something wrong with the timer because I accidentally like turned the timer back on, realized I hadn't put my YPT study timer on, so I need to turn that back on, so I think I lost a second or something. But anyway, so we're here. Anja, a quality control officer, wants a 95% confidence based on a sample size of 100 with a width of no more than 0.1 kilograms. What is the maximum standard deviation for this confidence interval? So, margin of error is going to equal 0.1 over 2, so be 0.05. And then say for 95%, confidence, we want that k is equal to 1.96. So this is going to be 1.96 on square root of 100. So we know sigma is going to be equal to, on a CAS, solve 0.05 equals 1.96 of x on square root of 100. So maximum is 0.2551. Over the next 50 days, Ben, who is a data collection agent, takes random samples of size 100, and each day is calculated for each 10 of these samples has a lower bound that is less than set to. Is Ben correct to justify your response? % of the intervals have a lower bound that is less than 1 kilogram. No. Oh, this one's tough. This one I think is yes, because the percentage of interval is much greater than the confidence should be. But it's only the lower bound, it's not the mean. So I'm going to say no, due to confidence intervals. Okay, due to only the lower bound being lower. The actual value may still be above 1.00 kg, but it is unknown. Due to the random, but cannot be determined, but whether the mean is too low cannot be determined due to the inherent nature of random sampling. I think this would be more convincing if 1 kilogram was higher than the entire confidence interval, because really we should only have 5% of them. Because if this is the lower bound being lower, that's fine. Because let's say they're like, oh, I need to charge my iPad. Let's say like the lower bounds, let's say like that's 1 kilogram. I mean, technically the lower bound is lower, but it's like 90% of the confidence interval is still above it. So yeah, I'm gonna say no. Okay, plane has that equation, determine a vector that's perpendicular to plane P. So, let's say that Z minus 2x minus y equals to 4. Therefore, normal will be negative 2, negative 1, 1. X, Y, and Z. Plus due to R dot N equal A dot N. Okay, write the equation for plane P in vector form. We have R dot negative 2, negative 1, 1 going to be equal to 4. Determine the acute angle correct to the nearest degree between plane P and line L. So we can figure out the acute angle from correct to the nearest degree between the plane P and the line L. So let's say I have a line here. So I'm going to find that angle. Now that angle is going to equal this angle. So the angle between normal and line. And then I'll say I did it on a cast. And what is it called? It's literally called angle. So angle of so the normal is negative 2, negative 1, 1. And the direction of the line is negative 1, 1, 2. So I want this, and it says to the nearest degree. angle of -2, -1, 1, and -1, 1, 2 is equal to 60. Oh, it doesn't want me to do the dot product. Ah, damn it, man. Okay. Probably wants me to do it, doesn't it? Okay, so I'll do it. Okay, where is, I just want to make sure it's a dot b equals cosine. Okay, yeah. So a dot b is going to have negative 2, -1, 1 dot -1, 1, 2 all over the square root of 6 times the square root of 6. It's going to be equal to cosine of theta. So theta is going to equal the inverse cosine of, it's going to be 2, 1, 1. 2 minus 1 plus 2, 3 and 6, so like half. And then this is, 60 degrees. Therefore, angle between plane and line is going to be equal to 90 minus 60, which is 30 degrees. Because I found this angle, which is that angle, but then the angle between the plane and the line is this angle, which is 90. So obtain the Cartesian equation of the plane 2 that contains line L and is perpendicular to plane P. Okay, so if it contains line L, then we can say that line L, 1, which contains line L, must be parallel to 1, -1, 1, 2. Contains 2, 1, 0. And I'll say here as perpendicular to plane 1 must be parallel to the normal, which is -2, -1, 1. Therefore, R is going to equal, oh, it wants a Cartesian equation though. Therefore, normal is going to equal to -2, -1, 1 times -1, 1, 2. Let's do the middle, so -2 minus 1, so 3. Middle is going to be -1 plus 4, so 3. And the bottom is going to be -2 minus 1, -3, which can equal just 3 of -1, 1, -1. Let's make sure I did that right. Action vector cross product -2, -1, 1, and -1, 1, 2. -3. Yep, okay. Therefore, R dot -1, 1, -1 is going to equal 2, 1, 0 dot -1, 1, -1. So then we have R dot -1, 1, -1 is equal to, that's going to be -2 plus 1, so -1. So then -x plus y minus z is going to equal -1. Okay. The We Love Yas Bank extends personal loans to approved customers. A random sample of n personal loans is taken, confidence interval of the population mu in thousands of dollars. What is the mean personal loan x dash in this sample? X dash is going to be equal to 10.2 plus 25.4 all over 2. Plus 17.8. Calculate the standard deviation of the sample mean. Okay, so 99%. For 99% confidence, if that k is equal to 2.576, and then we have margin of error is going to equal 25.4 minus 10.2 all over 2, so we get 5.2 divided by 2, so 2.6. I think 7.6. Oh, 17, yep. So then we have 7.6 is 2.576 of standard deviation, sample mean. Boom. So then boom is equal to, so 7.6 divided by 2.576 is 2.950. 3. Okay, Ali exclaims excitedly, everyone here has 99% certain that the true population is within this. Everyone here. 2, Ali is not correct. It's 99% certain. Not everyone is certain. So not everyone created this interval, so not everyone is 99% certain. Only the people that made the interval are. I don't like these questions. Okay, they did the sampling. Now I'm saying that the true population mean is within the interval. So I'm going to say it's not 99% confident, or not 99% certain. That this interval contains population mu. So maybe different people for this one. Different people can come up with a different their own confidence intervals. And that's 90% certain. The true population. Add the units there. It isn't. Did I say it's not 99% confidence? Is that right? No, I think that bit is fine. Everyone created the, so not everyone knows. So there are people that I think did something different. Their own 90% confidence intervals as they may end up with different sample sizes or standard deviations or deviations or that for the same population due to the inherent nature of random sampling. Random sampling. A data analyst discovers that the sample size was actually 2, and in addition to this, the sample mean was actually 2,000 more than originally determined. Recalculate based on the mean on the basis of this updated information. So we'll say that margin of error is going to be equal to 1 on square root of 2 of the old margin of error, which was 7.6. So this is 1 on square root of 2, 7.6, so 5.374. Mean is going to be $2,000 more, so it'll be 19.8. Therefore, 19.8 minus 5.374 is 14.426 less than or equal to 20 mu less than or equal to 25.174. Is that right? I think it did. New margin of error. Okay. A fly moves around a path given by a 3-dimensional curve. The fly's path begins at point A, mentioned below. Specify that. Determine the initial acceleration vector and indicate this clearly on the diagram above. So then V of t is going to be equal to cosine of t, 2 cosine of t, and then negative sine of t. A of t is going to equal negative sine of t, let's do this, negative 2 sine of t and negative cosine of t. And then A of 0 is going to equal 0, 0, negative 1. Indicate this clearly, so then it's going to go straight down like that. Oh wait, no, it's 2t. 2t, so this will be negative 4 sine of 2t. Differentiate sine of x. Oops, standard radians. Negative sine of x. Sine of 2x would be negative 4. Differentiate cosine of x would be negative cosine of x. Yeah. Calculate the length of the path taken by the fly, correct to that. So then that's going to be 0 to 2 pi of the square root of the velocity. So v of t is cosine of t squared. cosine squared of t plus 2, so 4 cosine squared of t plus sine squared of t, and it will all be in t, so the 2 pi square root of 5 cosine, wait, it's 2t. Okay, wait, let me get this. Plus sine squared of t. Okay, so this is just be cosine of x squared plus 4 cosine of 2x squared plus sine of x squared and all the x. And I'll probably take a second to load. Oh no, 10.541, assuming 3 decimal places. Yep, meters. Okay, sine squared. Yep. The shape of a decorative vase is modeled by revolving the curve A to B about the y-axis. Where is that? 0 to 7. All dimensions are in centimeters. Determine an integral expression in terms of h for the volume of water of the vase if it's filled to a depth of h centimeters. Okay. Then this is just going to be volume of water. So equal to pi from 0 to h. We're going to want x squared, so it's just going to be y of y squared minus 11y plus 35, and it'll be dy. And it wants an integral expression, so I don't have to calculate that. Water is poured into the initially empty vase at a constant rate of 50 centimeters per second. Determine the time taken to fill the vase to a depth of 6 centimeters. So volume equal to pi, and we're going to go 0 to 6y of y squared minus 11y plus 35. dy. So this total volume is 11x plus 5tx, 508.94 centimeters cubed. All dimensions, yep. So then t is going to be 508.94 all over 50. Time taken. It's going to be 10.18. Let's do 179 seconds. With the depth at 6 another added to the base, using the increments formula, calculate the approximate change in depth of the height of the water in the vase. So approximate h. I want this to be dh, dv, s of t, volume is equal to pi of h y squared 11y, oh god, plus 35 dy is equal to, so let's do this, so it's y on 4, so pi of y on 4 on 4 actually no so I'll say v equals that, so then dv dh is just going to equal pi y of y squared 11y plus 35 because I'm going to have d, dh out front. So I just sub in h for everything. Okay, so then dh, dv is equal to 1 on all of that. Oh, I need h of this. So pi h squared 11h. Therefore, dh dt. Wait, no, what am I finding? S of h. I want this to be a small change in volume. For S of v at h equals 6 and S of v equals 30, because these are all in centimeters. Yes. S of h will be approximately equal to 1 on pi, or 6 pi of 6 squared minus 11 times 6 plus 35 times 30, which is going to be approximately equal to, so 1 on 6 pi outside of 36 minus 66 plus 35 is 30, which is, oh, 1 on pi? What, dude? That's crazy. What is that 1 on pi? 71 minus 6. Oh, wow, okay. So 0.318. 3183 centimeters. Okay, function x is a rational function in the form of that with the following properties. Has a vertical asymptote, x equals -3. Another asymptote equation, x equals 5. So x plus d let's say, wait, -3 plus d equals, I'll say this is the vert asymptote. So we know that d equals 3. And then b and c. So then y equals x plus 5. What do I call this? Oblique asymptote. We have that x minus 5 plus k on x plus d, so x plus 3 y is equal to that. So y is going to equal x plus 3, x minus 5, plus k on x plus 3. So this is going to be x squared minus 2x minus 15 plus k, and then x plus 3. And then we have that f of 2 is -2. So we have -2 is equal to 4 minus 4 minus 15 plus k, all on 5. So -2 is equal to, what's it, -10 is equal to 4 minus 4 is 0, so -15 plus k, 5, therefore y, x squared minus 2x plus 10 on x plus 3. And then I'll say therefore b negative 2, and c is equal to 10. Wait, negative 10. Oh yeah, negative 15 plus 5. Negative 10. Calculate the exact area of the shaded region. So we want to go, x-axis negative. So area is equal to negative. So let's say y equals 0. So 0 is going to be equal to x squared minus 2x plus 10 minus 10. So let's say this is negative 5 and 2. No. X is equal to okay, these were not nice numbers. So this was 1 plus or minus square root of 11. And for area, it's equal to 1 minus square root of 11 to 1 plus square root of 11 of x squared minus 2x minus 10 all on x plus 3 dx. Negative. I'll say this here negative as below axis. And this is all equal to, I'll make that negative a bit easier to see. Copy that. So then negative 1 minus square root of 11. I know it must be square root. 1 minus on the bottom, because obviously that's going to be lower than 1. I'm going to have x squared minus 2x minus 10, and then x plus 3 dx, decimal 14.6. Oh wait, exact area. Standard. Okay, so negative 5 ln of square root of 11 plus 4 plus 5 ln of 4 minus square root of 11 plus 8 square root of 11. Apparently it's the exact area. Did I want me to do that by hand? Surely they don't mind. Surely they don't care about me doing that by hand. I could, but it's only 3 marks. I just had to do some casts. Okay. 20. A ball is projected vertically into the air from a point R so that it eventually hit the ground at point P, 3 meters from the base of a 10-meter high light at L. So it eventually hit the ground at point P. What's point P? Okay. From the base. At any time, t seconds, when the ball is h meters above the ground, it casts a shadow at the s meters. At any time, it can be shown that s is equal to 10 minus h equals 30. Show that the s dt is equal to that. Okay, so let's do so we have S10 of negative h equals 30. So let's differentiate this. So it's going to be a product rule. So we have the s dt times 10 minus h plus it's going to be negative dh dt outside of S equals 0. So then ds dt of 10 minus h is going to equal s of dh dt. And here we know that s is equal to 30 on 10 minus h. So ds dt is equal to 30 on 10 minus h times 1 on 10 minus h times dh dt. Is that what we wanted? Yep. So this is 30 on 10 minus h squared dh dt. Okay. At t equals 0.5 seconds, it is found the ball is 6.27 and moving upwards at 6. So the h of t. Okay, so h dash of t is going to be negative 9.8 t plus c. H dash of 0.5 is going to be equal to, upwards is at 6.1. So then 6.1 is equal to negative 9.8 times half plus c. So then c is going to be plus 4.9, so 11. So then h of t is negative 9.8 t plus 11. And h of t is going to be equal to, maybe I'll say here that h of t is the antiderivative h dash dash of t dt. And then similarly here, h of t is equal to the antiderivative of the velocity. So then this is going to be negative 4.9 t squared plus 11t plus, let's say this one is k. Now h of 0.5 is equal to 6.275. So then 6.275 is equal to negative 4.9 times 0.5 squared plus 11 of 0.5 plus k. Now k must be 2, but we'll just double check. 275 equals negative 4.9, 0.5 squared plus 11 on 0.5 plus x is 2. Therefore h of t is equal to 2 plus 11t minus 4.9 t squared. Okay. Determine the initial speed of the ball shadow correct to the nearest 0.01 meters per second. At 0. So let's say h of 0 is going to be 2. And then h dash of 0 is going to be 11. Therefore ds dt equal to 2 times 11, which is going to be 22. What? Initial speed of the ball shadow. So this is the initial speed. Oh, 30 on 10 minus h. Okay. So 30 on 10 minus 2 squared times 11. So 30 on 10 minus 2 squared times 11 to the nearest second decimal place, so 5.16 meters per second. Wait, is that right? So the h is here. We use the first derivative of h, okay. And then we found h of 0, which was 2. Yep. 2. Okay, how close am I? Oh yeah, 2 more pages. Wow. Wait, we finished this exam way quicker than the others. Okay. The graph of the function the SDT against time t is shown below. Point R of this graph corresponds to the ball being thrown into the air, while point P corresponds to the ball hitting the ground. Okay. The definite integral is with value to the area of the region. Determine the area is 13.45 in terms of the motion of the shadow. Change in S so the speed of the shadow the integral represents motion of the shadow represents the displacement of the shadow, the change in the shadow from t equals a to t equals b. Determine the value for a and b. The SDT, we go off that though. B corresponds area. Oh wait, the area of the shaded region is determined. Okay, wait. So A is 0, so maximum height. A is at the maximum height. So A is my ball is at max height. And then I'll say this is when h of t is going to be 0. Zero is going to be negative 9.8t plus 11. T is equal to, so 11 divided by 9.8, so 1.12 Therefore, A equals 1.12. And then B is when h of t equals 2, given that t is greater than 0. So then t is going to be, so solve 4.9x squared negative plus 11x plus 2. Equals to 2. So t is therefore negative 4.9 t squared. 11t plus 2 is going to be equal to 2, given that. So then t is equal to 2.24. Therefore b is equal to 2.24. Now this is the displacement from. You're back. My mother just came in, so we found A and B. Describe what this definite integral represents in terms of the motion of the shadow. So I'm going to say displacement of shadow, of both shadow, from t equals 1.12 to t equals 2.24. But then since it's going to be here and then at rest, change in s is actually going to be the full distance, the distance and the length of the shadow is, I'm going to say 13.43 meters. This represents the difference in the length of the shadow from the lowest point R to highest point of the ball's motion. Okay. Determine the fastest rate at which the shadow moves, correct nearest, and the time at which this occurs. So the fastest rate at which the shadow moves, ds dt is equal to 30 on 10 minus h squared now h was, here we are, then times dh dt. So this is going to be 30 on minus h squared, so 4.9 t squared minus 11t, and then it's going to be 10 minus 2, so plus 8 squared, times, now the h dt was which is actually negative 9.8 t plus 11. Graphing the SDT on CAS. Given that zero is less than or equal to when P corresponds to the ball hitting the ground. Wait. Let's point P. And h of t actually equals 0. So b is not that. B would be 0, 2.4. So b is 2.413. When cast, given that 0 that's not equal to t, that's not equal to 2.414. 141. Let's say that max at. Okay, so I go graph a table. This is going to be really ugly to graph. 30 times negative 9.8x plus 11, all on 4.9x squared minus 11x plus 8 squared. Graph view. Oh wait, it bounds. So then given that 0 is less than or equal to x, is less than or equal to 2.41. Oh, it does not like graphing this. Fastest rate at which the shadow moves. So maximum is at 0.77 and 17.47. And I'll say minimum at 1.47 and then negative 17.47. Looks like it's on the edge of my CAS. Is that so? Is this just because? Oh no, that looks like it. And absolute value of Vmax equals absolute value of Vmin. Fastest rate at fastest rate at which the shadow moves is ds. I'm gonna go with the positive one. So fastest rate at t equals 0.77 seconds. Vmax is 17.47 meters per second. Okay, we finished at 12:04, so I'm gonna get marking right now because I do not want to be doing this any longer. So So yep. Thank you guys so much for being here for the past about 20 exams I've done. It's been not the most fun. Sometimes it's been fun. Sometimes it's not been fun. But we shall see what we get for this last exam. So yeah. See you guys in a little bit. Welcome back to the last marking session we'll be doing. Pretty good score, 92.7. Pretty happy with that. It's definitely got up because I think we've been getting about 91, 92s. The past 2 or 3 exams. Let me see what I've been getting. 91, 91, yeah, 94. So yeah. So we're definitely in that low to medium 90 range, which is pretty solid. So let's go through. We lost 7 marks in calculator 3 and only lost 3 marks in calculator 2, which is pretty good. Here again, we lost this mark straight away. I remember I made this mistake before because it's due to the horizontal asymptote. Oh my god. So yeah, that's off. 1 mark gone. Here we got another mark because I didn't realize that we had to find whatever ZO was to then get, then we have to expand that and then get the A and B's from the expanded version with here instead of just this, which is silly, so I lost 2 marks there. Bless me. Yeah, this was good because 2023, I was like, if it's 2023, it's better, that's better be it. This was actually interesting because you could have said that this is not a one-to-one function, g of x, but it must have, I don't know what happened because they also said that this was an acceptable solution as well, which is interesting because yeah, it doesn't pass the horizontal line test. That completely skipped my mind. But I guess because it says it to sketch it on the axis below, people were like, oh, I guess I must have to. It doesn't say like if it's possible to sketch it, then sketch it. So I guess that. Here, this isn't true because x equals 3 is outside of the domain. Actually, also these should be y's, not x's. But I did talk about how it's compassed the range, and it should be in the domain. But yeah, the actual domain should be just being 1 to 3. Because here, when y is 3, there's no value for 3 there. So yeah, it's just being 1 to 3. And then absolute value stuff was good. It was pretty good. I think down here was also pretty good. Here, it was a tough one to call because I mean I still got the right answer because I only used the positive version. I guess I should have said plus or minus square root, which is fine, I guess. So what's the mark there? Got that mark all completely correct. And here, oh my god, yes, this was so sad because I would have got the marks here as well. Oh my god, but yeah. I just needed to get the correct exponent. I was actually, so close to getting this right. This is like the challenge question in the exam. 100% the challenge question. Yeah. Yeah, is this question 8? Yeah, it is question 8. But yeah, man, I would have been so happy if I got that. And really, I did get it. It's just that small little exponent error because I forgot to bring that 3 over. Or 3 to the 6 there. But yeah. You know, it is what it is. Oh, man, that would have been so good. Oh, sorry, no, 3 to the 2 there. Oh, that would have been so sick if I got that. But yeah, I lost quite a few marks in calculator 3, which is kind of sad. Usually I do pretty well. Usually it's calculator assumed where I fall off a bit. But yeah, we're going to quickly switch to calculator assumed now. Okay, here in calculator assumed, we only lost 3 marks. And I think they're near the bottom. We actually did very, very well through like most of these. Super duper well. This was also, I did this in a much simpler way. It should be a right angle triangle there. But I did this so much simpler. They were using cosine rule and everything. And I understand why, but like, didn't have to. No, you definitely did not have to. So yeah, here, you could have also said that only 95% of 95% confidence intervals will contain mu in the long run. It doesn't mean that your the lower bound being 20% of the time being lower than doesn't really mean anything. So yeah. Boom, boom, boom. I got 2 marks off here, which is 60% of the marks I lost, 66. I could have said any of these, but I didn't. It also explicitly said in the marking key that if you just said this, it wasn't really like it wasn't really valid for a mark. You had to explicitly say one of these. So you could have said it either contains mu or it doesn't, because they said 99% certain it does. So that's kind of, not true. Because we don't actually get told what n is, it just says n. N could be less than 30, so then it's obviously not going to be normally distributed, so then sample won't be valid. Repeated takings of size n, 99% of the confidence intervals will contain mu, and since mu is unknown, so then whether a confidence interval contains it or not is unknown as well. So, yeah, 3, that's a very small 3, however I'll leave it. But yeah, and then the next mark we lost is just down here in the explaining the shadow bit. I probably should have just said that it's a negative. See if I can make that bigger. Negative 13.43 instead of things 13.43. The fourth mark was for talking about the ball traveling from the highest point to the lowest point, but I said it represents the difference in the length of the shadow from the lowest point to the highest point. So I think you're talking about the same thing in a different context, but the mark was for talking about the lowest point and the highest point, so I gave myself that mark. But yeah, I just need to talk about the negative displacement, or the ball is moving towards, or the shadow is moving back towards the pole, the light pole. Yeah, and this was good. And it says fastest rate, so I assume that just means maximum, because they only talk about maximum there, they didn't even look at the minimum, so yeah. Alright, 3 marks lost, pretty happy with that, 92.7. I'll be pretty happy with that on WACE. It's actually 2:40 AM right now, on the day of the WACE exam, so I need to get to sleep. So, thank you guys for being here for the past, I don't know how many exams I've done. And also, it's so bad because I haven't uploaded like any of them. Well, I've uploaded I think 14 of them. But let me see. I've only uploaded I think half of the ones I've done. So I've got 20 videos up. The most recent one I've uploaded was a 2023 method one, which was 10 days ago. So I got 10 days backlog of exams to edit and then upload. I'm very sorry for that, but hopefully if you're watching this in the future, it's been somewhat helpful. I know some of the exams I waffle a lot and I get a lot of the questions wrong, so they're not that useful, but hopefully looking at the marking of my exams have been useful. And also if you get stuck on a question, and hopefully I did it right, you can see an actual student's thought process going through it. So yeah, because you will definitely see where I get stuck, where I just freeze for a little bit and I just think in silence. It's a bit awkward, but it shows you the raw process of it. And it's definitely not cut down, first of all because I'm lazy, and second of all just so that it's real. Because when you see people do these types of like questions online, they always have the solutions right there in front of them, and you're like, how did this person ever figure this out? Well, sometimes they didn't figure it out, they just found it from someone else. And second of all, if they did figure it out by themselves, they probably spent a lot of time like I do thinking about these questions. I remember in the calculator free one, that last question, I think that took me the whole 10 minutes or something to get in. And then in the end I didn't even get the full marks for it. But yeah, it is what it is. So WACE is about to be over for me. I still got things to do. I still got like performances to make and speeches to do and stuff like that. But WACE will be done for me. So studying will be done for a good while. So yeah. See ya.